Oh, okay. So today we are learning about transducers. The topic today is transducers. So we want to learn about electric transducers. First of all, this topic is not new. You have learned so much about transducers in the past lectures during your ND days and HND1. But today we are going to talk more about transducers, and some properties of transducers will be discussed. So we know that a transducer is a device that actually converts energy from one form to another. So we can also define transducer as a device that converts primary form of energy into a corresponding signal with a different energy form, which includes mechanical, thermal, electromagnetic, optical, chemical, etc. The transducer can be regarded as a device that takes the form of a sensor or an actuator. A sensor is a device that detects or measures a signal of stimulus, or that acquires information from the real world. So we have an example. An example is thermometer. An actuator is a device that generates signal or stimulus. Example is a heater. Example is a heater. So we talk about sensor, actuator, transducer. Transducer. So these three terms sometimes are used interchangeably to mean the same thing. Okay. Now the basic instrument system consists of three elements, which are a sensor. So we can use this block diagram to explain that. We have a block diagram to describe the basic instrument system. So what you have is the input signal coming in from here, which is actually usually physical parameter or other parameters. In the input, we have the sensor here, which is actually the transducer. Then we have the processor. And then the last part is the receiver. And the receiver now gives the result to the output. Alright. So the input signal comes in to the sensor. The sensor takes it and then captures it and then takes it to the processor. The processor works on that, processes it, and then gives the result to the receiver, which will be able to produce an output signal. Now take note, this block diagram is the instrument system. That one is different from what we learned last week, which is actually the control automated process block diagram. Automated process block diagram. It's almost the same thing, but with a little bit difference. So this one does not show the process, what the company or the industry is doing that requires a control system. It's not shown here. So that is the difference. Basically this one is about the instrument system, how it works, how the instrument system works. Alright? Now, there are physical variables that we're talking about that serves as input device. It can be temperature, pressure, temperature, pressure, it can be speed, flow rate, it can be force, movement, okay, and then it may be velocity, acceleration, displacement sometimes, Alright? It can be stress, strain, stress, strain. You know, it can also be weight, mass, density, volume, acidity or alkalinity, acidity or alkalinity, acidity or alkalinity. Okay, these are various input parameters that the sensor is actually can be applied to monitor. So those are input parameters that goes into the sensor, which actually is the transducer. There are many more than this, but these are the most common that we can talk about. All right. So now, measuring these physical quantities require sensors. Okay, and the sensor may operate an input device such as a switch, for instance, maybe on-off switch to detect the parameter. For instance, the parameters such as proximity, such as updates can be detected using a proximity switch. The level in a storage tank such as empty or full can be detected by a level switch. Hot or cold of a particular body can be detected by a thermostat. Pressure, whether high or low, can be detected by a pressure switch. So all those switches can serve as a sensor, the input device sensor. Alright. So a transducer is normally designed to sense specific measurement or to respond only to a particular measurement. Alright. So a complete knowledge of the electrical and mechanical characteristics of a transducer is important. It's quite important in order to actually apply or select a transducer for a particular application. Alright? So it is very important, quite essential to get details of these characteristics during the selection of instrumentation for a particular application of concern. And we have certain parameters needed, certain characteristics or properties of transducers that will help us select a proper transducer. So we want to talk about some of these properties in our next lecture. Remember to share the video and make your comments, ask your questions about the topic in comments. Ask about transducers, examples of input parameters, questions on that, you can comment down and then I will respond to your question. Don't forget to subscribe to the channel if you haven't done so. Smash the notification bell also and share the video so that others can also see it. See you in the next video. Bye.